continuing on lesson 2.7. Let's look over here and see what our learning goal is for today. Is it the same as yesterday's? Do you see it? Is the card kind of in your way? Didn't get very far, did I? What's it say? Okay, what was our learning goal yesterday? What were you doing yesterday? Well, weren't you solving absolute value inequalities yesterday also?
Yes.
But to do it, you had to set up a compound inequality. That was the process you could use to help you be able to solve them. So we still have the same goal. We need to know what do we do to solve an absolute value inequality. Yesterday, what kind of signs did our inequalities have in them? One of two signs. What was one of them? Yesterday, when we set up our compound inequality yesterday, it came from an absolute value inequality that had the what's symbol in it?
Bars.
Well, bars make it absolute value. I'm asking what inequality symbol were in yesterday's.
X.
Well, X was the variable involved in it. I'm
Greater
asking,
than or equal to.
was it is greater than or equal to?
Less than or equal to.
Okay, is less than or equal to? Is all of the above? All of what he stated? No. What were specifically? Okay, let's find yesterday's notes. Come on. We'll find it. What specifically, what type of inequalities were we solving yesterday? We have to know, because we got to be able to keep it straight, what kind does
Absolute
what.
value.
Less than,
So we were solving absolute value, Devante?
less than, and less than 2.
Okay. If it had the is less than symbol in it, in the absolute value inequality, if the inequality symbol was is less than, or is less than or equal to, then to be able to drop the absolute value bars after we got the absolute value expression by itself, what kind of compound inequality did we set up yesterday?
And.
The and or the or one? The and type. Because basically when it says is less than or is less than or equal to, we're basically saying it can't be any more than that. It's got to stay within this restricted region. It can't go out any further than this. So we had those two endpoints. It couldn't go any further than, so it became an and compound inequality. Is less than or equal to. That was yesterday's type. Today's type, I want you to circle that right now in your notes so that you can see, you don't forget, or it helps you to draw attention to, what if I have the is greater than symbol in it, or the is greater than or equal to symbol? What am I going to do then? Because it's different. So the absolute value of x is greater than or equal to 5 says that x must have a distance of what? 5 or more, right? So at least 5? So we'll say at least 5 units from 0. So the absolute value of x, so we're saying the distance of x has to be greater than or equal to 5. So its distance has to be at least 5 units from 0. That's what it's telling us. Okay? Therefore, we're going to be able to say, what are the things x can be? So what compound inequality do you think we can set up here? X what? What numbers are at least 5 units away from 0? Abby? Negative 5 and 5. So x has to be more than or equal to negative 5, right? Because starting at negative 5 on the number line and beyond going that way, did I write that correctly? How do you feel about that? If we want numbers that are at least 5 units away, did I write that correctly? X is greater than or equal to negative 5? What numbers are greater than negative 5? Negative 6? Negative 7? Negative 4? Yes. Negative 3? So what symbol do I have to use there? The is less than. I have to use the is less than symbol there. So we can't be confused by just because it started with an is greater than or equal to. We're saying x has to be either negative 5 or something smaller than negative 5, because those are the numbers that are at least 5 units of distance away from 0. Or, what are the other numbers that are at least 5 units of distance away from 0. What's the other part of this compound inequality I could write? What about 5?
X is greater than or equal to 5.
X is greater than or equal to 5. So, starting at 5, and anything bigger than 5, those are all at least 5 units away from 0. So this is an OR situation. We have those guys starting at -5 going to the left. We have these guys starting at +5 going to the right. That's an OR. So there's our compound inequality we would set up for that type. Okay, so what does the next one say? The absolute value of 2x is greater than 8. That says 2x, because that's what's inside the absolute value bars, must have a distance of what? Can it be 8? No. It says absolute value of 2x is greater than 8. So this means distance. Anything above 8. So a distance of more than 8, do we say? Okay, so a distance of more than 8 units from 0. So see if you can write a compound inequality that shows 2x being more than 8 units from 0. Go ahead and try that. Therefore, in that therefore spot. Therefore, how would you show 2x being more than 8 units from 0? Okay, who's willing to come up here right there's on the smartboard? It's easy, your finger just magically writes it. You have no idea? You want to try it, Cody?
Sure.
Okay. You can bring your paper up if you need to.
The whole inequality or just part?
The compound inequality we would set up to show 2x having a distance of more than 8 units.
So you see the finger.
Now, just right with your finger. Okay, thanks, Cody. Anybody else have more Cody has? Okay. Okay, there's 4 people who agree with you, Cody. Okay, so we got half the class that likes that. So let's evaluate that and see if those 5 are right. Okay, it says 2x, you know, the absolute value bars aren't there anymore. Its distance has to be less than -8. In other words, basically saying all the numbers that are smaller than -8 have a distance of more than 8. Do you agree with that? So like -9, -10, -11, -100, do they all have a distance of more than 8? Yeah? Okay. This says 2x and is greater than 8, so now we're thinking about all the numbers bigger than 8, so like 9 and 10 and 20 and 100, and do all of those numbers, 9, 10, 20, 100, do they all have a distance of more than 8 units? Are they more than 8 units away from 0? Yeah, they are. So this is the correct way to set it up. This is how we can get rid of our absolute value bars. Okay, so here's what we're going to do now. We practice solving. To get the first thing we have to do, just like we had to do yesterday, get the absolute value part by itself. It has to be by itself before you can set up your compound inequality, ditching the absolute value bars. Get that absolute value part by itself. Then set up, what kind of compound inequality are we going to set up today? Or. We need to set up an OR one today. And then finish solving both simple inequalities if it isn't just x. If x isn't already by itself, then you got to do some more to get it to be. Okay? Okay, so let's go do some practicing of that. Okay, so we have, for number 1, the absolute value of 2x is greater than 8. Oh, there's that one we were just talking about. We're going to solve it. Okay, so do we have to get the absolute value expression by itself? Or is it already? Is it all by itself? Yeah, there's nothing being added to it, subtracted from it, it's not getting multiplied by anything, it's not getting divided by anything. So we can just do what Cody and 4 others agreed with. We could set up our 2x is less than negative 8, or 2x is greater than positive 8. So we set up our compound inequality, where we ditch our bars, the absolute value bars, and now we're going to decide that we have to do another step to solve it. What do we have to do?
Divide both 8's by 2.
Okay, so we have to divide 2x, so we're solving each of these separate of each other though, aren't we? So we'll solve the first simple inequality. We are going to do the same step in both, but we have to solve them separate of each other. So now we have x by itself. Did we divide by a negative? Remember that rule?
No.
No, we didn't. So we don't have to switch the symbol. Negative 8 divided by 2. Negative 4. Bring down the or. Remember, we bring down the word or in between. And then we do the same step in the other one. Divide both sides by 2. We didn't divide by a negative, so we don't have to switch the symbol. There's our compound inequality solution. Cody.
If you had your 2 negative and you did that, it technically wouldn't change to an and, would it?
Change to an and? No,
Yeah.
it would not.
Because if you add your negative 2, you get x is greater than 4, or x is less than negative 4. So technically it would stay the same, right?
But what would end up happening is because it's an or one, the whole number line would be shaded. So everything would count. It would be all real numbers if that was the case. Because or means it can come from any shaded region, right? It doesn't have to come from the overlap only. Okay, let's graph this. We have to graph them just like we did for today, like we've been doing with all inequalities. Are the negative 4 and the 4 included with a shaded circle?
No.
Okay, open circle with those guys. Where's it shaded? In between? What's up, ladies? Got a question? Oh, okay. Where's it shaded, Jossie?
On to the opposite side.
Okay, this one says less than, so you gotta go this way. The other one says or greater than, so you gotta go this way, and it can come from either region, can it? Okay, so any questions on that one? Okay, what should we do in number 2? What do you think we should do? Same thing? Something different? Is the absolute value expression by itself? That's the first question. And subtract 2. What's happening? Is the absolute value of x being added to 2, or is 2 being added to the absolute value of x? Because remember, subtracting would undo adding. Is that what's going on? 2 next to absolute value bars means
Multiply.
multiplication. So what are we going to do to undo the multiplication?
Divide.
Divide. We need to divide by 2. And are we going to set up our compound inequality right away, or do we just divide by 2 first?
Divide by 2
So
first.
we got to divide by 2 first, because this needs to have the absolute value expression. We have to do something to get it by itself. It isn't by itself yet. So we have to divide by that 2 so that we can get that 2 that's in front of the absolute value expression out of there. And now we have the absolute value of x is greater than, did we divide by a negative?
No.
No, so 2 divided by 2 is
1.
1. Okay. Now the absolute value expression is by itself. What would we do next? Set up the compound inequality, right? Okay, what would it be? X is less than negative 1.
Or x is greater than 1.
This says the distance of x has to be more than 1 unit. So all the numbers less than negative 1 have a distance of more than 1. All the numbers greater than 1 have a distance of more than 1. So there's our compound inequality. Do we have another step to do?
Subtract.
Is x by itself? Yeah. We've already actually, just in setting up the compound inequality, it's also the solution. And now we can just graph it. We didn't have that extra step to do. Open or close circles? Open. Numbers less than -1 go this way. Numbers greater than +1 go this way, and it's the typical, what we call the typical OR graph, where they do go opposite from each other. They're opposite regions. Okay? Okay, so let's go to the back and see what kind we're going to practice here. Okay, what do you think is our first move in number 3? Add 7. Add 7 to both sides because why? What's our reason for doing that? To what? Well,
Or simplify it down.
kind of like that. We actually are really eliminating step because we're doing a step, and we're kind of simplifying it down because what's our goal? What's always the first thing we need to do? To get the absolute value expression by itself. We're not even worrying about x right now. We're just worrying about getting the absolute value expression by itself. So we're adding 7 to make that happen. So then we have the absolute value of x is greater than or equal to what? 3 below, the temperature goes up 7 degrees, it's now? It's 3 below 0.
4.
And the temperature goes up 7, it's now 4 above. Absolute value expression is now by itself. So now, Devontae, I want you to tell me what I'm going to do next.
X is less than -4, or X is greater than +4.
Okay. No equal to bar?
Oh yeah, equals.
Equal to, is that kind of important in this one? Yeah? Because this says x's distance has to be at least 4 units away. 4 or more. So all the numbers starting at -4 and headed left, less than, they all have a distance of 4 or more. And same thing, x is greater than or equal to 4, starting at +4 and heading right. So is that one solved already? I'm going crazy and graphing it already. How come? Because it's done. X is already by itself, isn't it? So we need closed circles this time, shaded in circles this time. And we're going to shade according to what our solution tells us. Okay, you try the next one on your own, number 4. The next one on your own. Run through all the questions that I keep asking you. What do I have to do and why? Okay, volunteer to go work number 4 on the board for us. Hey, Aurora, your turn. And let's just use a different color so it stands out from that number 3, okay? And if you're going to go crazy and work ahead, you can in these notes, but make sure you have a good eraser on your pencil in case something goes wrong, because you want to have good notes. believe, I'm just gonna do this, so it's just to really make a point what part is shaded, because they're kind of about the same. So, how many of you agree with Aurora that this is the correct way? Yeah, and this is how it should be in your notes. You need to make it an or. Do we ever combine, when we're doing an or compound inequality, do we ever combine the two simple inequalities into one statement that does not use the word or, like we do in an and? No, we never do that. We always have to write two simple inequalities with the word or between them. So what step did you really get to skip in this one? Getting the absolute value expression by itself. And we do not want to just go right to adding 3 to both sides, because that 3 is involved in the absolute value part. So we can't mess with it until we get our compound inequality set up and get those absolute value bars out of there. Okay? Okay, what's your first move in number 5?
+1.
Add
Why are we going to add 1?
because it's outside of the absolute value.
Got to get the absolute value expression by itself. So we're going to add 1 to both sides, because that subtracting 1 is outside of the absolute value bars on that side. So we have to get that out of there. And then we're ready to say the absolute value of 4x plus 6 is greater than what? What's it greater than? 10. Okay, now are we ready to write our compound inequality? Okay, Noah, what would the compound inequality be for this one?
4x plus 6 is greater than negative 10. Other way,
That is greater than, that's what you told me to do.
less
You meant is less than?
Yeah.
Okay. Okay, so is less than, okay.
or 4x plus 6 is greater than 10.
Okay, did I write it the way you wanted it this time?
Yeah.
Okay. He is correct. Okay, so now that we have our compound inequality set up, our OR, go ahead and solve it. And be really careful, just like in the last one, remember, the endpoints aren't always going to be opposites of each other. So don't just solve one of them and say, oh, the other one's going to be this then. It's opposite. You have to solve both of them separate of each other. Okay? There's somebody done that hasn't been up here yet that wants to finish this for us. Jossie? Come on up. Okay, let's change colors now. Next color. Okay, everybody agree with Jossie and her smiley face? Did she have a good problem there? Did she do it well? Yeah, well, most papers that I did get a chance to get around and look at had this same solution. Okay, good job. Okay, any questions? Okay, Michaela, you're gonna do number 6 while everybody else is working theirs. Come on up, you're gonna teach this one. You guys can go ahead and start working number 6. And if you have questions of Michaela, just, nicely ask. If you're doing it different than she is and you want to know why, it should be done that way. Show me, just like she did right there. After you divide by 3, show it with what happened with the absolute value bars, and it allowed you to set up the compound inequality you did. Skip that step.
Can I scroll down?
Can you, yep, you can scroll down.
No, like to the far.
Oh, it doesn't have any more room to do that, so we can maybe sneak it in there. Good job, Sneaky fingers. Okay. Why are you doing that? Where's your pencil? Okay, let's use that. Can't make mistakes, you can't. By the way, you can always gently challenge a teacher, whether it's Mrs. LeGrand or one of your peers. Okay, so if you want to challenge, just say, Michaela, I have a challenge. Think, somebody might want to talk to you.
You forgot that there's an equal and an equal. Oh, equal to sign?
So, is that important? Is it important that we worry about? Absolutely, yeah. We've got to make sure that equal to part doesn't get dropped off and left behind, or that we add it when it wasn't there in the first place. Thank you, Michaela. Okay, any other challenges? Or do we like this answer? Good answer? Do you agree with it on your notes sheets? So I guess we're ready to start working on homework, huh? Go ahead. Thank you to all of you who came up and helped me out today.